Welcome, my name is Joey Dickhans. I'm a performance specialist in the technical marketing organization at VMware, and it's my privilege today to go over the performance new features and best practices for Vsphere 5.1. So hopefully you guys are in the right spot. I'm joined today with Sri Sethi, who is in our performance engineering team at VMware down here in Palo Alto, or down the street in Palo Alto, and he'll be going over some of our networking and Vmotion material later in the presentation. All right, going through the disclaimers here, agendas, jumping right into it. Just to get sort of our bearings straight here, I just wanted to give a little bit of an overview of where we've been and where we're going. So obviously you guys are pretty much familiar. In the early days of virtualization, we were going after all those low-hanging fruit applications, those web servers, DHCP servers, all those small little things, one-way applications, small memory size footprint applications. We were able to virtualize those quite easily, which brings us where we are today with 24 million virtual machines running on vSphere today. More workloads running virtual than there are physical in the industry out there today. Increasing at a rate of about 9% plus every year over year. And today we're going after these nice tier 1 applications. So we're going after the larger applications, the ones that require a little bit more resources. That's what we've been focusing on over the last couple of years. And so we're going after the Exchange, the SQL servers, the databases, SAP, et cetera. We do a little survey of our customers every so often, and we ask them, of these tier 1 applications, are you virtualizing them in your environment? And we found that a lot of the customers that we were asking come back and say, yes, we are already virtualizing these tier 1 applications, and that those numbers continue to increase. You can see there, Exchange has about 42% of our customers already virtualizing Exchange to some degree in their environment. So we're continuing to climb up this tree, getting those tier 1 applications, and of course the clouds flew in there, so we're of course going after the clouds as well. Now the reason why we can virtualize these applications, these larger applications, is because of course the platform has gotten better over the years. And so the capabilities in the platform have just continually increased and continued to increase. Here we're just going to show a little comparison, just a visual representation of the requirements of your typical application. Now this is a typical, well maybe not typical, but this is a SQL Server, which we consider a tier 1 application. This is a typical size of a SQL Server application according to the capacity planning information that we got from our customers. So we get a lot of data back from our customers about the size of their workloads, and this is what we found was the typical size of their SQL Server workload. And it was a really modest size workload. 2 CPUs, 4 gigs of memory, 100-something IOPS or less, and less than 1 megabyte per second worth of networking bandwidth. So the requirements that these tier 1 applications need were relatively small, and when you compare that with what vSphere 5.0 can provide you, you can see that the capabilities of vSphere 5.0 just totally overshadow the requirements of your application, of the typical application. Now, admittedly, SQL Server tends to be a relatively smaller size tier 1 application. Your Oracle databases, your SAP installations, they get to be a lot larger. And so we recognize that. And so we've increased our capabilities yet again in vSphere 5.1. And in 5.1, now we can just basically blow away those requirements of your applications. We can totally handle it with inside of a single virtual machine. These are per virtual machine numbers here, where we've got 64 vCPUs per virtual machine, 1 terabyte worth of memory. We now were able to prove 1 million IOPS from a single virtual machine, and more than 40 plus gigabytes worth of network bandwidth per virtual machine. So huge amounts of capability in a single virtual machine that just totally blow away the requirements of your tier 1 application. Even if your tier 1 application or mission critical application was 10 times larger than this typical one, 20 times, even 30 times larger than this guy, we've got you covered in vSphere 5.1. So what is vSphere 5.1 going after? Well, it's going after those big applications. Big data applications, high performance computing applications, Hadoop. We're going after the mega monster applications, large scale vSphere deployments. We're going after that, making sure that we've enhanced our management tools, so vCenter server, that we've enhanced that so you can manage larger applications, larger deployments of vSphere. And of course, we're going after vCloud Director improvements and view improvements as well. All right, so let's look at some of these in more detail. So in the core platform area, probably the big new feature in the core platform area, quite literally big, is our mega monster virtual machine, our 64-way virtual machine. So there he is, 64-way. He's 2 times monster of a virtual machine. 1 terabyte memory still, but still 64-way. And of course, the use case for this is those much larger applications, our Hadoop applications, our high-performance computing applications like NAMD there, mega-sized databases, Oracle, mega-sized SAP installations. That's what we're sort of going after with the Mega Monster. Now, throughout this talk, I'm going to sprinkle in the best practices. There's actually a slide after each one of the resource categories with the best practices in it, but throughout the talk, we'll sprinkle in some of the commonly asked questions, commonly asked best practices. When we talk about Mega Monster, and even in vSphere 5.0, the monster 32-way virtual machine, customers quickly asked, well, is there any performance impact for running a larger sized virtual machine? And the answer is yes and no. There's actually not a huge performance impact from running a larger sized virtual machine if your application needs the larger sized virtual machine. So if you have an application that scales well and can take advantage of all those vCPU resources, the vSphere scheduler can schedule it quite easily and run it perfectly fine. We can scale up an application pretty much exactly identical to how that application would scale up in a physical world. So if the application is perfectly linear and can double for every doubling of resources, we can double it for every doubling of resources for the most part. Pretty much near identical performance from the physical world. The other question is, can we mix and match large monster virtual machines in my environment with a bunch of 2- and 4-way smaller virtual machines? And the answer is yes, you can still mix and match. You know, if you have an environment with lots of 2- and 4-way virtual machines, you can have a couple of 32-way virtual machines in there, no problem. You can have a whole environment with 32-way virtual machines. The scheduler, the vSphere scheduler, is very, very adept at being able to handle all those different types of workloads. However, there are some little corner case caveats. So if you have high availability has some policies where you can say, I want to make sure that I reserve enough capacity for one EXX host to be able to fail and still have enough capacity to support my entire environment. When we use that type of high availability resource allocation control mechanism, we have a slot size. And the slot size is dependent on the largest size virtual machine in your environment. And so if you have one very large outlier, then you might have some issues with the slot size in your high availability environment. The easy workaround from that is don't use the per how many EXX hosts do I want to reserve off, just use the percentage. So if you guys are familiar with high availability, you've got two options. You've got I want to reserve capacity for X number of hosts to be able to fail, or I want to reserve just 25% of the capacity in the environment. If you do it by 25% of the capacity, or whatever percentage you want to give it, if you do it that way, it doesn't use that slot thing, we don't have any issues there. All right, little tidbits there. All right, moving on, we also are supporting in vSphere 5.1, we're supporting the latest Intel hardware, AMD hardware, so we're supporting the Ivy Bridge and Sandy Bridge from Intel, the Pile driver from AMD. We're supporting more physical processors per EXX host, so we're supporting 256 processors in a single server running vSphere 5.1. And another nice little interesting feature here is that we're supporting virtualized CPU performance measurements, performance counters. And the idea here is that virtual machines are becoming extremely popular everywhere, right? So almost anywhere in your IT and industry organization, virtual machines are going to be being used. And a lot more often these days, the developers are actually developing code inside of a virtual machine. This causes a little bit of a problem because some developers, when they're tuning and optimizing their code, they use very deep dive performance tuning capabilities, performance products like vTune and Code Analyst, that can actually grab performance measurements from the physical processor itself and report those back. Things like cache misses, actually at the chip level, cache misses, cache hits, things like that. How long did it take to execute the instruction at the chip level? When we virtualized that, we virtualized away those performance counters previously to 5.1. Now with 5.1, you can enable this feature, and we can up those performance counters up to the guest operating system, to the application, so that vTune and Code Analyst can actually grab those. And your developers that are developing code inside of a virtual machine can now have all the tools they need in order to optimize and tune their code while they're developing it. All right, another little tidbit of information here. A frequently asked question is there any difference between the Intel and AMD? Well, you're not going to get me saying any differences. Not when Intel and AMD are both in the room potentially, and they might attack me afterwards. But really, the advice here is use your industry standard benchmarks. So if you've got an industry standard benchmark that's comparing two different models of hardware and different chips and whatnot, different configurations, use those. They're pretty good representations of how well it's going to perform in a virtualized environment. And of course, we have VMmark, which is VMware's benchmarking suite or tool or whatever you want to call it, benchmark, that we use and our hardware vendors use to benchmark their appliance, their hardware and their hardware models with a virtualized environment. So use that as sort of your comparison to determine which way. The other question we get asked a lot is, does it make a huge difference if I have 2 sockets with 6 cores or if I have 6 sockets with 2 cores? Generally, that doesn't make a difference. There's not a huge amount of difference from performance reason either way. If we wanted to sort of recommend one direction, the fewer sockets typically results in better performance only because it reduces the number of NUMA nodes, which tends to be better performance. But again, look at those industry standard benchmarks, look at your VMware benchmark data to sort of get a better information about how your different models that you're trying to compare up. All right, another new feature in Vsphere 5.1 is a latency sensitivity setting at the virtual machine level. Now, this is a new little cool feature. We've actually had white papers and other documentation out there to talk about how to tune the vSphere environment into virtual machines for latency-sensitive applications like VoIP applications that really need to be able to process those incoming network packets very quickly and be able to receive them off the wire very quickly. We've had those white papers in the past, and you had to read through them and make the tunes manually. Now what we're trying to do is try to simplify that a little bit for you. So now you can go into the virtual machine edit settings screen and set this one little setting. It has 3 different levels here, normal, low, high. You can set that to indicate that you have a workload that's latency sensitive. So now you can basically specify that this virtual machine is going to be running a latency sensitive application. It will go in the background and change those things that were recommended in the white papers, like the interrupt coalescing, the machine CPU prioritization. It'll do that for you. The one little caveat here, and it's in the red text at the bottom, is that use it a little bit cautiously. Much like the white papers had suggested, all the applications are somewhat different. And even if it's a latency sensitive application, it might respond differently depending on how we tune it. So these are not just a panacea across the board. Just don't set it for pretty much anything that you think is latency sensitive. Make sure that you've tested it, that you've run this in a development environment, you've tested it, that you've seen that it gives you the performance gains that you expect, because some latency sensitive applications actually perform slightly worse when we enable this. The other thing is also, don't just go out there and set it on all your virtual machines. Otherwise, it's one of those things where if you try to make everybody special, nobody's special. So attempt to avoid that as well. All right, some of the CPU best practices here. Again, if you guys have been around the block, which I know pretty much most of you guys are at VMworld, these are probably some common to you. But again, size your virtual machines appropriately. So don't use the mega monster virtual machine if you've got a single-threaded workload, right? That's not going to be as efficient. It's just going to be wasteful. Size your virtual machines appropriately. That's one of the benefits of vSphere is that you can size the virtual machine according to the workload size. So size things appropriately. Try to stay inside of a NUMA node if you can, both in terms of CPU and memory. That'll give you the best performance. Oversizing your virtual machines, like I said, may be less efficient. This isn't necessarily an indicator of vSphere or a problem in vSphere. It also happens inside the physical world as well. If you've got a much larger physical box than you have a workload that needs it, you actually will probably be burning more CPU resources than you would if you had sized that appropriately. So make sure you size things correctly. The hint here about using resource settings like reservations and limits only in your environment if you need to. There's nothing really wrong with using reservation and limits. Feel free to use them when you need to. The concern here is that we don't want you to go through all the administrative hassles of setting them up on each virtual machine, potentially changing your workload later on and forgetting to recalibrate those reservation and limits. So this concern here is more from an operational concern. We just don't want you to forget about them. So our recommendation would be up-level it, put those things on the resource pool, so at least you have less objects to track, that you're not doing it at every individual virtual machine. If there is a particular individual virtual machine that you need to protect, go ahead, feel free to protect it with reservations and limits. But remember that you're going to have to administratively remember that those things are enabled and keep an eye on them. Avoid setting the affinity. We do have the capability inside vSphere to set the CPU and memory affinity, so you can bind a virtual machine to particular sockets, particular CPU cores, and particular memory banks. Again, for administrative hassle, we don't recommend you doing this. vSphere is very good at optimizing where it's placing virtual machines, and so let vSphere do it. Again, if you go in there and manually do it, you might see a little bit extra performance from doing it. However, the administrative and potential dangers of forgetting that you had done it outweigh those benefits for the most customers. All right. Last little bit here, make sure you check your BIOS for your physical server. So go into your BIOS for the physical server, make sure you've got hyperthreading enabled, you've got turbo boost enabled if you've got turbo boost capabilities. Make sure you've got the power management setting, that's the big one. Make sure you got the power management setting correctly for whatever your goals are. So if you want maximum performance, make sure it's set for maximum performance. If you want maximum power savings, make sure it's set for maximum power saving. Since Vsphere 5.0, we've had the capability to change the power settings from the vCenter level. So if you go into your guest OS from your physical box, You can change the BIOS setting to be guest OS controlled, and then vCenter can now modify those power management settings on the fly, so you can change your goals if you want maximum performance or if you want maximum power savings from vCenter without having to reboot the box every single time. All right, one last one. We've evolved. The scheduler has evolved significantly over the years. One little thing we had introduced in 5.0 was the ability to change the cores per socket. So this is the representation of cores per socket when we present it to the virtual machine. So now when we create a 4-way virtual machine, we have the option directly from the GUI. It was there in the past through secretive hidden little command line edit settings in the VMX file. Now we have it right there in the GUI. If you want to create a 4-way virtual machine, you can decide that you want a 2-socket, 2-core virtual machine, if you want a 4-socket, 1-core virtual machine, if you want a 1-socket, 4-core virtual machine. You've got all those options right there in the GUI. From a performance standpoint, it doesn't make any difference for the vast majority of cases. It is slightly used for our vNuma capability, but for most customers, whatever representation you want, it's mostly there for licensing reasons. All right, into memory management. We only have one real new memory management feature in vSphere 5.1. And this is a feature that allows us to swap out certain system memory from the vSphere system processes out to a swap location. And we got a cute little animation. So we power on one virtual machine, we power on another virtual machine, we power on another virtual machine. We attempt to power on this last virtual machine, and we just don't have memory for them to fit in physical memory. It'd be nice if we had a way to swap out that system memory so that we could power on that last virtual machine. This is from the web client. This is easily configurable in the GUI in the web client. By default, it is enabled, but by default, it's not actively configured. I don't know, that's the R&D guys. So it's enabled, which means that if you have one of these three options that is configured, it will use that as its swap location, and it goes in order. So if you have configured a data store for it to use as the swap location for this system swap file, it will use that, but you have to configure it. If you've configured host cache, it'll use that. Again, you have to configure it, but by default, it will use it if you have configured host cache someplace on the EXX host. And then lastly, if you've configured a local host swap file, local host swap directory on your EXX host, it will use that by default. However, all those things are not configured by default. So by default, this thing isn't actively going to work for you until you've configured one of those three options. All right. If you do configure it, though, it creates a system swap file on whichever location in priority that you have configured for it. Then it can swap out some of the system world memory locations out to the disk, and that allows the extra virtual machine to power on. This is actually more of a reservation thing. So we want to make sure that those system memory, system processes can fit in memory, and so right now we have a reservation for it. Those things need to be able to be in memory when we need them in memory. So we have this reservation, and we block it, and it's about a 1 gig worth of a reservation that we can actually free up by doing this. So what we do is there's that large memory reservation for these processes. When we configure a swap location, which is 1 gig in size, we can reduce that reservation, and immediately things can start using it. We don't actually have to swap out the memory pages. We just are able to reduce that reservation so that now we can tell vSphere that, yeah, you can use that memory because in case we do have memory pressure, we've got a place that we can put these very important memory pages temporarily. All right, that brings us to this last little chart here in the memory section. Since 4.0, we've been backing all of the memory pages from a virtual machine, if we could, with large pages. And that's changed the dynamic of transparent page sharing. So transparent page sharing only works on small pages. This is one of these questions we get asked a lot as customers look in their more recent versions of vSphere on more recent hardware releases and hardware platforms, and they notice that their consumed memory is a lot higher than it was in the olden days. And they call us up and ask questions about it. That's perfectly fine. Consumed memory being high is how it's designed to work now. We want to be able to use as much memory in your box as we can get access to. So it's good that we're using that memory. If you do memory over commitment and you get into memory pressure, that's fine. We'll consolidate things down. We'll break those large pages into small pages. We'll do ballooning, and we'll free up memory. Not a huge problem. The thing you want to keep an eye out for capacity planning, though, is active memory. So how much of that memory that we've allocated to those virtual machines are the virtual machines actively, constantly touching? And this is a 4-minute sample period. 1 to 4 minutes, it's complicated. But there is a talk, unfortunately, it goes on exactly at the same time as this talk, but you'll have to get the slides later. Down there at the bottom, very good talk that goes into a lot more detail about the memory management capabilities in vSphere. But the key point that I wanted to make sure you knew is that Consumed memory is going to look high. It's going to be basically 92%, 95% on your server as long as you've allocated that type of memory to your virtual machine. It's not going to have that transparent page sharing from the get-go. So it's always going to look pretty high. When you look at your environment, look at that active memory setting to see how much of it is actively being touched. And when active memory gets to start to be high, that would be the performance concern that you might start having problems where that active memory is getting swapped out or ballooned out. All right, here's some of the memory best practices. Again, memory overcommitment is perfectly fine. Typically, our customers start at around 120% over allocation, so about 20% memory overcommitment is perfectly fine for most customers. This is a typical general rule of thumb. So if you don't have an idea of the performance impact, we would say start at 20, keep an eye on things, see if any EXX host level swapping is occurring, any guest level swapping is occurring, and adjust dependingly. So if you notice that you were able to do 20% overcommitment and you weren't seeing any swapping and no performance impacts, you can go higher. If you're seeing that there's performance impacts, you have to back it off, all right? Here's some of the risks. So as we do memory technologies or memory overcommit technologies are enabled, this is what we go in order. So we have first attempt ballooning, and ballooning has very little impact as long as we're ballooning pages that aren't being used by the guest. So if we go to the guest operating system and say we need some memory pages back, and the guest operating says, oh yeah, here's a whole bunch of them that I'm not even using, no problems there. We're not going to have any performance impact from that. There is, however, a medium-sized risk, though, that we will say we want these many memory pages back. Windows or Linux will come back and say, okay, well, I can give you these, but that's going to cause me to have to swap somebody else. We're not going to know that. So you have to keep an eye on in-guest level swapping that could occur if you see your ballooning driver kicking up pretty high. Going down the list, the other one is transparent page sharing. It's got a pretty low impact if transparent page sharing is kicking in. So if you see high levels of transparent page sharing, that's probably not a performance concern to you. It's just goodness. It's reclaiming memory that it can through consolidation of identical pages. We also have memory compression and host cache capabilities that have been introduced in the previous releases of vSphere. Those have pretty medium to high impact, though. So once you start using those, the performance is going to start to get affected. And then very, very high impact is the host level and EXX level and guest level swapping. Again, sizing is very, very important. Best practices here, performance best practices. So size your virtual machine to fit inside those NUMA domains so that we can get all local access to memory if we can. All right. Storage. Jumping along in storage, we've made 2 improvements in storage I/O control. So hopefully you guys are familiar with storage I/O control. We introduced it in 4.1. Am I right? Yes, I think. 4.1. We introduced storage I/O control in 4.1, and it allows you to create disk shares that balance across the entire data center. In the past, disk shares were only enforced at the per EXX host level. Now with storage I/O control, those disk shares are enforced across the entire data center. The other nice thing that storage I/O control does in 4.1 and beyond was that it had a congestion threshold latency. So you could set a latency value that you wanted your storage device to be at or below. So say you would want your storage device to be able to respond back to you within 30 milliseconds. Storage I/O control would monitor your storage device and say, oh, look, the latencies are creeping beyond your congestion threshold value. What storage I/O control would then do, it would kick in and throttle back the virtual machines and the I/O traffic going towards that storage device so it can reduce the latencies off of that storage device. The benefit here is that we would throttle it back based on the disk shares and prioritizations that you set up. So your high priority virtual machines would get better access to performance. They would see those lower reduced latencies, where your lower priority virtual machines, they might get throttled back a little bit more. They might see higher latencies, but that's okay because that's what we want. We want those higher priority virtual machines to get the better latency. In the previous releases of storage I/O control, the congestion threshold value was a static value. It was set in milliseconds. The problem here is that storage disk mechanisms are different. So we recognize that there's SSDs out there. They have a different profile than a traditional rotating storage mechanism. So what happens with storage I/O control is it's somewhat of a balance here. We try to get the maximum amount of throughput that we can get out of that device at the lowest latency that we can get it, right? Because we want storage I/O control to kick in right when we've hit the maximum amount of throughput that we can get out of the device without going into higher and higher latencies. So here we can see a little chart where we can see throughput and latency sort of plotted. This is sort of hypothetical. And we notice that by the default one for an SSD device, by default it was 30 milliseconds. That might be putting us at a higher latency than we could have if we had reduced it to a lower latency value, but getting the same exact throughput from the device. Now with storage I/O control in 5.1, we can set not a millisecond value, but actually a throughput percentage value. So we can say we want 90% of the total amount of throughput that that device can handle. We want you to start kicking in at the 90% level. And it'll automatically determine where is that 90% value in terms of latency, so you can get the best latencies from that storage device without sacrificing throughput from it. The other nice little feature we included in 5.1 is that we're now bringing where we monitor the latency up a little bit. So in the past, we measured the latency values at the storage device level. So the HBA, anything in the hardware, so from the HBA, the wire, at the storage. Now we're bringing it up so that it monitors not only the device latency from the storage array and the hardware components, but also the software latency from the vSphere kernel itself. So this is if you've got a lot of virtual machines running on one EXX host, and it's not the storage device that's getting congested, it's actually say the vSphere software queues that are getting congested. So something in the vSphere stack is getting congested. That's when we would also like storage I/O control to kick in and prioritize our virtual machines to prevent that bottleneck from causing us a performance concern. So we've up-leveled this. So storage I/O control is great at responding to very quick changes in storage performance and responding to bottlenecks and performance concerns very granularly, very quickly. What we introduced in 5.0 was storage DRS, which allows us to load balance across data stores in a data store cluster based on the capacity and I/O capabilities of the data stores at that time. It's a little bit less granular, so it's looking at a much larger period of time than storage I/O control is. Now we mentioned that storage I/O control up-leveled where it's monitoring things. Storage DRS uses that new value, so it uses the storage I/O control values, latency values. And the nice thing about it is now, in the past, it would load balance just based on the hardware latencies. Now it's also load balancing based on the software, vSphere software latency. So if you are getting that bottleneck at a software queue inside one of your EXX hosts, it'll move some of the workloads around to a different EXX host where maybe it's not going to be as bottlenecked on a queue over on that side, or an HBA is bottlenecked or something. So it'll be able to load balance across EXX hosts, even if the bottleneck is occurring at the software stack and inside the vSphere software stack, because we're now monitoring it at a higher level. All right, the other thing that we've introduced in 5.1 for storage DRS, and the key thing here, is that we want to be smart on when we do these migrations for performance reasons. If we're going to migrate a VMDK and take all that time to do a storage Vmotion, which is a lot more heavy, intensive operation than a regular traditional Vmotion, if we're going to take that time to do that, we want to make sure that it's a smart move. So we don't want to move a VMDK from a data store that's backed by the same exact spindles as another data store that we're attempting to move it to. If those things are backed by the same exact spindles, the odds are that the performance is going to be exactly identical when we move it over. We had capabilities previous to 5.1 to try to detect that correlation, but it required the use of the VASA APIs, and it required that the storage vendor and the storage array actually responded back with us with enough information for us to be able to determine that these data stores were correlated. Today, in 5.1, we now use our I/O injector to detect correlation. So what we'll do is we'll spit I/O at the data store when the data store really isn't doing anything, so we're not going to impact performance when we do this. But we spit I/O at it, and we detect whether or not the latencies increase on any of the other data stores. And so when we're spitting I/O at one data store A, if we detect that the latencies on data store B start to spike up, and when we stop, they drop off, we can detect that those two are correlated, and we won't make a move for performance reasons to try to balance out the performance, because we know if we do, those things are backed by the same spindles, it wouldn't make sense. So that's a new feature that we had in 5.1. We no longer require those VASA, because a lot of the customers didn't have VASA enabled, and a lot of the storage arrays weren't providing back the right information for us to be able to detect the correlation to begin with. The other thing is, the question we get asked a lot is, can we use storage DRS with auto-tiering storage? And there's a lot of philosophical debate here. The top one is follow your storage vendor's guidance on that, so make sure that it's supported and compatible with your storage vendor. The problem here is that there are so many different types of auto-tiering storage. There's block level, there's LUN level, there's so many types, there's so many different storage vendors, there's so many different algorithms that they use. So out of an abundance of caution and being conservative, VMware's guidance is if you are going to use storage DRS, and it's perfectly fine to do it, if you are going to use it with auto-tiering storage, for right now, we would recommend capacity monitoring only if you're going to have it in automatic mode. So it's going to make all the decisions and do things all by itself, in which case we would prefer it not using the performance, because it could slightly, in some cases, might do something silly, and we don't want to impact your performance for silly things. So if you're going to have it in automatic mode, do it with capacity monitoring only. If you're going to do it in manual mode, feel free to have it in both capacity and performance because you're going to look at it before you implement the recommendation, and you're going to be able to say, oh, no, that would be silly because I know that these two are either correlated or that this auto-tiering is already doing something better for me than this recommendation would be. So that's the guidance from VMware. But again, make sure you follow your storage vendors' best practices because they know exactly what their storage is capable for and how they've architected their auto-tiering capabilities and whether or not it plays nicely with us. All right, a couple other quick little things that we did in 5.1. We supported 16 gigabit fiber channel support in 5.1. And as you'd expect, 16 gigabit, double the throughput as 8 gigabit fiber channel. Woohoo! Awesome to allow for higher bandwidth, higher throughput for your applications that are needing a lot more access to storage. The other thing, though, is kind of nice is that it's more efficient. So for about 3 to 15% CPU efficiency per I/O, so cost of I/O, is actually much more efficient on the 16 gigabit fiber channel cards than it is on the 8 gigabit fiber channel cards, which is kind of nice. So you get a little bit of a gain there on the CPU side. So just fun things. We do support the 16 gigabit fiber channel HBAs now. Other new little thing that we did is we supported jumbo frames for hardware-based iSCSI. Now, we've had jumbo frame support for software-based iSCSI and NFS devices in the past. We've now added it for hardware iSCSI devices. Now, jumbo frames and enabling jumbo frames has been a best practice from the beginning of time, from when we started supporting jumbo frames. It's been a best practice. We've recommended to our customers a lot, and they implemented it and said, there's not really much gain for doing it. It's too much of an administrative hassle to talk to my networking guy to get it configured throughout the entire stack. And so it lost favor. That was in the 1 gigabit world. In the 1 gigabit world, we recommended it. We still recommend it. But for most of our customers, they didn't see huge gains in doing it. And sometimes those gains didn't outweigh the administrative costs of having to go and enable it across your entire stack. Now that we're seeing 10 gigabit Ethernet cards being very prevalent in the environment, we strongly recommend it now. In order to be able to saturate that much larger pipe, we need to have those jumbo frames enabled. And so we did a quick little study here from our performance engineering team to just show you what the difference is of having jumbo frames enabled on a 10 gigabit card versus not having enabled. And we'll just pick the top one there because it's the biggest number. On the hardware iSCSI side, read throughput increased by 88%. So huge gains when you have that jumbo frame enabled when you're using the 10 gigabit Ethernet cards. And again, like I said, the 1 gigabit Ethernet cards didn't show as big of a gain, but 10 gigabit cards, much more important for the jumbo frames. All right, wrapping up some of the storage best practices here. Again, sizing is always the most important thing in this talk. Size your storage array correctly. Make sure you have enough spindles to back the workloads that you need. If you are going to be running into a problem, it's probably device latencies. So keep an eye on DAVG, your device average latency. If that starts to creep above 20 milliseconds, 30 milliseconds, somewhere in that range, depends on who you talk to, but 20 milliseconds to 30 milliseconds, if it starts going beyond that, pretty much most applications will start noticing some sort of performance impact. It depends on your applications. If it's less storage sensitive, maybe it can tolerate more, but most like to be under that 20 to 30 millisecond range. There is a kernel latency, so like I told you, storage I/O control is now monitoring both device latency and kernel latency. Kernel latency generally should be 0. What we like to see happen is the virtual machine issues us an I/O. We just spit it right through our software stack and get it out into the hardware, get it start processed by the storage array. We don't want it to have it spend any amount of time inside the vSphere kernel. We grab it, we spit it out the wire. However, if things are congested at the back end, if the HBA is congested, it might have to sit in our software-based stack for a while before we can get it out on the wire. If it's sitting in our software-based stack for more than 2 milliseconds, that's probably a little bit of a performance concern. We like to understand why is it not getting out onto the wire. So if you see kernel average latency greater than 2 milliseconds, you might either have a queue that's undersized, or an HBA that's overloaded, or a wire, or something on the back end that's overloaded. All right, so keep an eye out for both of those things. Virtual machine snapshots aren't free, so they try, if you're running in a production environment, especially for storage-intensive applications, not to have snapshots just always enabled. Just kind of use them sparingly. They're perfectly fine to use, but try not to just keep it always there. So if you're going to be patching your server and you want to have that backup copy, take the snapshot, patch your server, test it. Once you know that it's working, remove the snapshot so that you don't have that snapshot just always there, because it serializes your I/O because it has to update this one little snapshot file. All right. Utilize storage I/O control and storage DRS in order to protect the storage performance for your higher priority virtual machines, and so that it can load balance across all those data stores that you've got in your environment. And then again, make sure you remember the oldies and goodies. The virtualized device drivers, we still recommend them. Nowadays, there's really no reason why you shouldn't be using them across the board. In the past, you couldn't boot from them for most of your guest operating systems. These days, most of the recent guest operating systems actually have the paravirtualized device driver support for booting. Some of them even have the driver already built into it, so you can just install to it without even having to install the driver. You can actually just install to it because it already has the drivers built into it. All right, so utilize the paravirtualized device drivers pretty much across the board, especially if you have storage-intensive applications, though. If you don't have the storage-intensive applications and you don't want to go through the administrative hassle, all right, fine. But if you do have storage-intensive applications, make sure you are using it. We still recommend balancing across vSCSI adapters, but for the most case, you probably don't need to because a single vSCSI adapter can handle 100,000 plus IOs per second. So unless you're driving a lot of IO through a single virtual machine, you probably don't need to balance across vSCSI adapters. But again, it would be best practice if you're getting to be very high intensive IO rates. Follow your storage vendor's best practices. We can't say that enough. All right, now I'm going to pass it over to Sri, who'll go over the networking and Vmotion portions.
Yes. Hi, my name is Srikanth Sethi. I work in the performance engineering team at VMware. Today I'll be talking about some of the new networking features we introduced in vSphere 5.1. And then I'll also talk about some of the best practices to keep in mind. Okay, first and foremost, we are introducing support for single root IO virtualization. It's a new standard that enables you to present a one PCIe Express adapter as separate multiple logical devices to virtual machines. Okay, this feature essentially enables you, basically it gives you the same benefits as VM direct path, which include reduced CPU cost and reduced network IO latency. So how is it different from VM direct path? With VM direct path, you needed to dedicate a physical NIC to a virtual machine. So even if you have a 10 or 20 virtual machines on your host, you really couldn't get the benefits of direct IO because it was not feasible to have so many network cards, right? SRIOV removes that limitation. Because with SRIOV, even with a single physical NIC, you can present it as separate logical devices to virtual machines. So even if you have a single physical NIC, you can get the benefits of pass-through technology. Okay, just a caution here. We don't recommend this technology for all the customer environments, mainly because SRIOV prevents you from using any virtualization advanced features like VXLAN, Vmotion, and so on. But if you have any specific situations that demand extreme network performance, you will find this very helpful. For instance, let's say if you have any networking applications which are very latency sensitive, with the end-to-end latency requirements of less than, say, 10 microseconds, you will find this feature helpful. Because in our tests, we've seen SRIOV reduce the network latency by about 5 microseconds compared to a para-virtualized VMX-Net 3. Okay, similarly, if you have, let's say, some networking applications which deal with extremely high network packet rates, okay, in excess of 100,000 packets per second, again, you'll find this feature quite helpful. Because in such environments, we have seen the CPU savings up of about 45% compared to VMX-Net 3. So again, the key takeaway is this technology is not for all the environments, but if you do have specific situations that demand extreme network performance, we have this feature available for you. Okay, VXLAN is a very recent but it's very powerful technology that VMware created in partnership with various networking vendors, including Cisco. This technology essentially enables you to decouple your compute and storage capacity from your underlying physical network infrastructure. So the idea is you should be able to take your VM, deploy it and provision on any physical host where you have compute capacity available, regardless of the physical network configuration. So clearly this is meant for mobility. The VM can move on any physical host without worrying about the physical network configuration. And on a single VXLAN, which can span multiple physical network, you can create any number of virtual networks as possible. In fact, you can create as many as 16 million virtual networks. So you can clearly see this technology was created with scalability and mobility in mind. Okay, and the best part is you don't need to really upgrade any of your existing networking gear to deploy VXLAN. So let's just take a quick look at the performance. So we've done a number of performance tests in our labs, comparing the performance of VXLAN with the performance of a default configuration which has no VXLAN. And we varied both message sizes and socket sizes. And you can see that in all the scenarios, the performance that we've seen on the VXLAN configuration is almost identical to what we've seen on a default configuration without VXLAN. So as you can see, performance-wise, we are pretty good. What about the CPU cost? It turns out that there's still some CPU cost which ranges from 0% to 30% overhead. Some overhead is expected because VXLAN by definition is an encapsulation technology. So for every packet on VXLAN network, we need to account for encapsulation overhead at the source and some decapsulation overhead at the destination. And also the current generation network cards don't have any offload features that support encapsulated packets. Okay, so there is some overhead, but the good news is almost all the networking vendors are gearing up to support offload features even for the encapsulated packets. So the key takeaway here is if you have cloud computing requirements which require some scale, you will find VXLAN benefits very, very compelling. And as far as the performance is really good, we can reach the line rate with VXLAN. And there is a little bit CPU cost, but you can expect it to significantly come down in the very near future. Okay, and here are some general networking best practices. Firstly, keep in mind that if you're using converged networks, it's a very good idea to use network I/O control so you can isolate and manage all your traffics. And if you're not switched to distributed switch, we strongly suggest you to do so. So it lets you use all the advanced features like VXLAN, Vmotion, VXLANs and network I/O control and so on. And there's really no performance impact. And in general, we suggest you to upgrade to your latest NICs, and so that way you can use all the new offloading features that I was just talking about. And also just keep an eye out for any packet loss and network latency, because more often than not, any networking problem means you have a higher latency or some packet loss. So let me just switch gears now and switch to Vmotion. In each vSphere release, we introduce new functionality to Vmotion, increased performance, and increased reliability. And this vSphere 5.1 release is no different. And Vmotion in vSphere 5.1 introduces you a number of new enhancements. Firstly, we are removing the requirement for shared storage. So if you have a source host and a destination host, you can do a Vmotion even if there's not a single common storage element between these hosts. Okay. Secondly, we are also combining your traditional Vmotion and a storage Vmotion into a single operation. So we have a still traditional Vmotion. You can also do storage Vmotion, but we are also allowing you to do a unified Vmotion. So what is unified Vmotion? It lets you migrate the entire execution state of a virtual machine, which consists of CPU and device state, the memory of the VM, and the virtual disks. All this entire execution state can be transferred in one single operation. So how do we do that? Just the way we transfer memory on the Vmotion network, we use the same Vmotion network to transfer the disk content as well. Okay, so earlier you had to do Vmotion followed by a storage Vmotion or vice versa, and also you needed a common storage element, but you don't need all this. So this shared nothing, a unified migration should give you tremendous amount of simplicity and flexibility in managing and moving all your virtual machines across your infrastructure. So let's just take a brief look at performance. I would like to present these slides because they give you dissection of traditional Vmotion and unified Vmotion. Here, I'm showing in this current scenario, I had a virtual machine which was running IBM DB, a solid DB, which is a database server. So what I'm doing is I'm plotting the database server throughput. Okay, I guess I can't reach this here. Before, during, and after the live migration. And as you can see that a traditional Vmotion uses shared disks. That means we don't need to transfer the disk's state, right? So that's why it only has a memory copy phase. And you can see that after the memory copy phase, there's a switchover period during which we had to quash the virtual machine on the source host and resume it on the destination host. So there's a brief drop in throughput which is expected. And you can also see that during the memory copy, the impact on the guest is very minimal because pre-copy is very, very highly optimized, and we don't really disturb the guest during the live migration. Now, if you compare the same thing with unified vMotion, you can see that apart from the memory copy phase, we also have a disk copy phase. And you can see that first we migrate the disks, and following that we migrate the memory. And one interesting thing you should note here is during the memory copy phase of the unified vMotion, we are not only transferring the memory, we are also transferring some of the disk changes as well, because this is a live migration, right? So as we're copying memory, which can take minutes and so on, or it can take seconds based on how large the amount of memory that you have configured for the virtual machine, you can expect that the VM is still running, and so the guest continues to change the disk. So we need to change the disk changes as well. But you can see that even though we are changing both disk as well as memory changes in the memory copy phase, the duration of the memory copy phase in unified vMotion is pretty much identical to what we see in traditional vMotion. And the impact is same as well. And we have a lot more such performance studies done comparing unified vMotion with storage vMotion too. And in all our studies, we haven't seen any impact at all. So the good news here is you get significant amount of flexibility and simplicity, and really zero cost for performance. And we are publishing a paper on both VXLAN performance as well as on vMotion performance. And if you're interested, do check out those papers. So we are also introducing some new features in storage vMotion. As you can see, we now enable you to migrate 4 VMDKs simultaneously. So especially this feature is useful if you already are having a virtual machine that uses anti-affinity storage rules. Okay, finally, let me quickly touch upon some of the best practices to keep in mind. Unified vMotion uses a number of performance optimizations that depend on the 1 MB block size that we use for in the VMFS layer. So if you have any VMFS file systems, let's say VMFS3 or 3.1 or world VMFS file systems, and if you're using a non-default block size, which is other than 1 MB, let's say maybe 2 MB or 3 MB, we strongly recommend you to upgrade to VMFS5 as well as 1 MB block size, because we have lots of optimizations that use 1 MB block size. And you can see significant reduction in the migration time. And if you're using multiple NICs for vMotion, we suggest you to configure all the VMK NICs in the same IP subnet, okay, and configure each VMK NICs to use a different VM NIC. That way, vMotion can transparently load balance all the vMotion traffic among all these VM NICs. And if you're migrating a virtual machine that has snapshots or link clones, one thing you need to keep in mind here is we use the vMotion network to transfer all the active memory and active disk content, right? But as far as the read-only state concerned, we transfer that using a management network. So if you do have VMs with snapshots, keep that in mind. You may want to provision a management network which is at least 1 Gbps, so the migration times are much faster. And even though we use network to copy the disk content in the unified vMotion leverages a lot on the existing traditional vMotion and storage vMotion. That means we try to avoid the use of network unless we really need to. So if the source host has access to both source and destination data stores, we leverage the storage vMotion, and so you do the local copy instead of using the network to copy the disk content. Obviously, it will reduce the CPU usage as well as the network usage. Similarly, if you have a storage array which supports VAAI, once again, we try to offload the copying of the disk content to the storage array itself using VAAI instead of we manually copying over the network. Again, to reduce the CPU cost and the network usage. So let me give back to Joey.
Okay, so I'm going to go back over to on. So I'll go over the vCenter stuff. So vCenter server also got improved in Vsphere 5.1. Here's a couple things you're going to notice right off the bat. So hopefully you guys are very much familiar now with the, ooh, it kicked in. Hopefully you're very much familiar with the Vsphere Web Client. So it's the new front end for all of your management of the vSphere environment. So configuring all your virtual machines are going to be in there. It's pretty much all the new features or capabilities are going to be in the web client going forward. There's a few stragglers, so plugins and things are still in the old client. We recognize that. We're getting them migrated over to the new client. It also uses a back end, a single sign-on server. And so some of the performance studies we've done here is that for the web client, we're able to support about 300 concurrent users. This is a 200% increase over the previous client. The other nice thing is, of course, the web client is web-based, so you can access it from pretty much anywhere. It is flash-based, so anywhere that is flash-enabled. The single sign-on server can support tons and tons. I know. I tried to get that through without anybody hearing. OK, anyway, single sign-on server, it can support thousands, tens of thousands of transactions per hour. So it can easily support all those 300 concurrent sessions that are coming at it. So the single sign-on server is pretty nice for the authentication as well, easily able to handle all the transactions and authentications that you would have in a large data center environment. A few other back-end improvements we made to vCenter Server. We've enhanced the database. So we had some very smart database guys go in there and tweak all the stored procedures for the database, especially around how they handle rolling up the statistics. And so this is, again, going into the acknowledging the fact that we're getting much, much larger data centers with a lot more objects in it. And so we needed to be able to collect those statistics. There's some customers that really want to collect all the statistics at stats level 4 for these very, very large environments. We don't necessarily recommend that. Our recommendation would be leave it at the default level 1, only bump it up to the higher level when you absolutely need to, and then once you're done analyzing whatever you were analyzing, bump it back down to level 1. But because of the back-end database improvements we've made, you can run it at stats level 4, and the back-end can keep up with it now. It can do 80 million transactions per hour, which translates to a massively large environment. We've got some of the statistics there that we tested with 1,000 vSphere hosts, 2,000 concurrent database data stores, tens of thousands, 10,000 powered-on virtual machines, all at stats level 4. So it was able to keep up with that pretty nicely. Some best practices for sizing it. The best practices guide for vCenter Server actually has some of these recommendations in it. It gives you sort of the guidelines on how many hosts you need, or how large a number of CPUs and memories you need for the amount of hosts that you're expecting to run in your environment. The trick here is, though, there's two different elements. How many hosts or how many objects, hosts, VMs, data stores, are you going to be managing through vCenter? And how active are those things going to be? How many power-ons on the virtual machines are you going to do? How much activity? How much churn? How many things are we going to have to keep track of? Those two elements dictate how large of a host you're going to need for your vCenter server. The other thing is vCenter Server now, because it has the web client, comes with a few other components to it. So it's got the single sign-on server. It's got an inventory database that is sort of like a cache location for the web client. So the web client doesn't have to go back and access the database anymore. So we have this inventory service that's in there as well. Questions come. Should I spread them out? Should I keep them together? It doesn't really matter. It's up to you. We do allow you to spread them out if you want. By default, keeping them together is probably the right thing to do, so you don't have the administrative hassle of all these things. Plus, we do need fast internet connection between them because, again, that inventory service is a cache location. It'd be nice if that cache location was very, very close and very fast for the web client. All right. The other thing is that inventory service is not using the backend database. It's using its own local little database, which would cause some I/O. So your vCenter server will now have a little bit higher of an I/O footprint, so you might need to consider giving it a little bit faster storage in order to keep up. Other things, sizing your vCenter server is important, but also sizing the backend database that your vCenter server uses is important, so make sure you keep an eye on that. There are some sizing guidelines for how much storage footprint they will require, but there's also some best practices guides on how many CPUs and memory those backend databases require. The other thing we have customers ask a lot is, how large of a cluster should I have? I don't know why we threw it in this particular presentation for vCenter server, but we have the question of how large of a cluster should I have? How many hosts should I have in my cluster? It's really up to you. It's how many clusters do you want to manage, how big of a cluster you want to manage. From a performance standpoint, it really doesn't make a huge difference. But just to give you some guidelines here, typically we see our customers running host clusters of about 8 to 12 hosts per cluster. Just as a guideline, totally up to you. You can go higher, you can go smaller. A lot of the locking and things, and not really a problem for us. Other things, do keep an eye on, again, stats level. How much stats level logging are you doing in your environment? The backend database performance, and the network connectivity between all of those components, the backend database, the web client to the vCenter, et cetera, et cetera. All right, last little quick side here, performance monitoring. Performance monitoring needs to be done throughout the entire stack. In the early days, we might have warned you off from using the in-guest measurement tools, saying that the in-guest measurement tools were inaccurate in virtualized environments. Ooh, did we say that way back when, and did that scare customers away from using them? Yes, it did. That's not incredibly accurate anymore, right? The real question here is you do need to do performance monitoring across the entire environment, but where do you start? So you should start right there at the virtualization layer, because the measurements and statistics at the virtualization layer are probably going to be accurate. We have good understanding of what's going on beneath us. Nobody is going to be lying to us underneath us. As long as that looks good, it's perfectly fine going up a level and looking at the guest OS measurements, so perfmon or SAR inside the guest operating system. As long as the virtualization level isn't lying to the guest operating system because of something going on at the virtualization level, the in-guest measurements at the guest level are going to be perfectly fine. So start at the virtualization layer. If there's a problem being detected there, go down the stack as appropriate. If there's no problem being reported there, go up the stack as appropriate. And again, those guest measurements are perfectly fine as long as the virtualization layer is saying that there's no problems. Of course, vCenter Operations is great. It can monitor across all those different layers. If you have the right plugins, it's very well tuned into vCenter, so it knows exactly what's going on with vCenter and can give you nice little analytics on that. It does the health, so what is your workload currently doing? How well is it currently performing? It does the risk analysis. We know what is the trending. Is it about to fall off a cliff with performance? Is there something that's causing it to start getting slower on the disk side or the networking side? So it does nice trending. It also does nice little efficiencies because we got capacity planning in there as well, so it does the efficiency. It can tell you if you're over-allocated or under-allocated throughout the environment. And it's nice little dashboard, so you can see the nice little red dots even in the far corners of this conference room. You can kind of see the little red dots in the dashboard. You can drill down into those and easily see where the performance problem might be, so you don't have to drill into every single object inside vCenter. Downstairs is the performance labs, so is the hands-on labs. There is a performance lab in there, so I encourage you to try to take HOL Inf 04, so hands-on lab infrastructure 04. It's the performance lab. There's actually 3 different labs built into one. So there's a basics lab that goes over basic things like ready time, co-stop time, things like that. So if you've been around VMware for a while, you probably don't need the basics one. There's an advanced one that goes into troubleshooting Java applications with vCenter operations and goes into a little bit more advanced stuff. And then there's a couple of fun lightning labs that go into some benchmarking tools and some other flings that VMware has. And then there's some other sessions, and I think that's pretty much it for us. We're going to leave that slide up. We've got a lot of people from performance engineering here. So we've got Todd, who can answer SAP performance questions. We've got Sri, who can answer networking questions. We've got Krishna, who can answer EXX top vSphere questions in general. And of course, I'm here. Thank you again for attending, and welcome to any questions up here.